Now, on the other part of the data book, you may have noticed some of these rings here, the red rings. The red rings highlight single N's and single O's. Single N's and single O's, this N as well, you could put them on as well, these N's as well. Any single N's and any single O's have got lone pairs of electrons on. So you draw lone pairs of electrons on the N's and the O's. And then you do what I call the Ghostbuster effect. You don't let the streams cross. And so you end up with 5 intermolecular hydrogen bonds. Okay, so you've got bonds here, an N to an H is a delta plus, because you've got a hydrogen bond in the NH and you've got a lone pair of electrons on the O, so we can link those to the top two easily. Then we go round one either side, and the lone pairs of electrons on the N link to the delta plus on the NH, because the H is the N is very electronegative, so that's going to be a polar bond, forming a hydrogen bond with that lone pair there. And then we go round again, the lone pair on the oxygen can form a hydrogen bond then with the delta plus on the NH, because that's a very polar bond, a hydrogen bond here, very, very polar bond, forming a hydrogen bond across to the lone pairs of electrons on the O, because the N here is electronegative. Electronegative large delta plus bonding across to the O. So I've got 3 bonds between guanine and cytosine, and the streams, the bonds, the hydrogen bonds, don't cross. In the remaining part of my Ghostbusters picture, I've got the 2 bonds here, one from the top on the lone pairs of electrons on the O, linking to the delta plus on the NH here, this very, very polar bond with the N being electronegative. And here I've got another polar bond with the N being electronegative and a delta plus, finally going around the outside to the lone pairs of electrons here on the N. So I have 2 sets of intermolecular bonds, hydrogen bonds between the adenine and thymine, and 3 between the guanine and the cytosine. Let's have a look at my question now. It says, how does this complementary strand in a helix, how complete the base pair diagrams showing the interactions? So let's try and identify this first of all. I've got an NH2, an NH and an O, an NH2, an NH and an O. There it is, NH2, NH and an O. This is guanine. Guanine here I can identify as guanine here from my O, NH, NH2N, O, NH, NH2N. I can identify it here in my guanine O, NH2, NH2N. It's slightly turned round in this picture here, but that's guanine. So what will guanine link with? It will link with cytosine. So what I do is I draw a cytosine alongside. And now what I do is I work out what's going to bond to what between guanine and cytosine. Well, on the guanine, the O with the lone pairs of electrons is going to link to an NH2 on a cytosine. The O with the lone pairs of electrons here is going to link to an NH2 with the cytosine. What else? I've got an NH on the guanine linking to an N lone pair, an NH on the guanine linking to an N lone pair, and then finally I've got an NH2 on the guanine linking to an O lone pair, an NH2 on the guanine linking to an O lone pair. The problem is my streams cross, so I'm going to have to flip this over like this, flip it over, I'll show you it back again, flip it so that the NH2, the N and the O line up properly, flip it, and then the streams don't cross, or rather the hydrogen bonds don't cross. Now even better, if you drew the lone pairs of electrons on the O, and the lone pairs of electrons on the N, and the lone pairs of electrons on the O, and the delta pluses on the H's of the NH, NH, and NH here, and that will get you all of the marks.